Hello, and welcome back to the shack. As most of you that are regular followers know, that I've kind of been off the air for about 2 years or a little over, but now I am slowly getting things put back together. And if you remember from the Huntsville videos, I did purchase a new radio, which is set up here on the table. I have a laptop to my left, an external monitor to my right. I got two lights on the wall, one behind me, and the overhead lights are on. Um, Set up what appears to be a pretty decent USB camera and my old faithful toner USB mic. I do have other options for microphones that I um, may try a little bit later on. But today's video is about the basically the building process that I went through of the ZS6BKW. I had heard about this antenna many times, but never really took time to look into it all that well. I did watch a series of videos on let's see, budget ham radio, and there is a screenshot of his page, and I will have a link to his YouTube channel in the description below. But since I do have a remote antenna switch, the ultimate goal is to have one coax leaving the shack and have options, we'll say, of antennas in the field or the little area behind me. Uh, I it's not much use in having a remote antenna switch with one antenna. So I've got a couple in mind, and the second video for the antenna switch will be coming up when I get a couple of more antennas in the air to be able to switch from them and compare them. So stick around and let's look at the bill that I went through. Look at some of the web pages, and we'll go from there. All right, this web page is the one that I base my measurements on, and I'll have a link to it in the description of the video as well as the other links. And there's several out there to look at. So, but the main radiators are 46.8 foot each, with 39.1 foot of 450 ohm ladder line and a 1-to-1 current balance at the bottom. That's pretty much exactly what I followed dimension wise when building mine. Now, like I said, I bought a 250-foot spool of the wire as well as 50 foot of the 450 ohm ladder line to build it out of. All right, now I'm going to show you a couple of pictures in the beginning of the build process just to show you what it was like. All right, now I personally like to use FreeCAD for my design software. And if you can see here, this is the first revision of the lid that I made. And you can bump it up. You see there is a section that does protrude into the box on this one. It is solid. After having to go through the um, wire versus coax build, I noticed that it wasn't going to fit too well. So I took that and I modified it so that it had this recess. See, this is protruding through the inside the box, and then this piece is recessed back up to the same level as the bottom of this lid, and it did fit. It was tight, but it did fit. Now, as far as the top, it's just got the tension holes, the bolt holes, tie downs, and tension support for the 450 ohm, as well as the string, rope, whatever you're going to use to hang the center up in. The feed point is basically the same way. It's the box with the chamfered sides where I could have the bolt holes in it. The recessed part where the lid fits in, 2 bolts, SO239 mount at the bottom, and I should have, in afterthought, made the depth of this deeper where I could have had 4 bolts, but as it was, I was able to lay the SO239 horizontal with the back and get 2 bolts in it. And the top, well, there's the bottom, and the 2 bolt holes for the connection to the common mode choke inside. The top is just like you see here with the 3 on each side for the strain release. And there's the bolt holes protruding through it. Now, here's a general overview of all of the parts. Before I put the SO239 in, my guess is the original lid and the FT240 toroid, the complete feed point. I have both radiators cut, and I have not cut the 450 ohm ladder line. And here is the dipole center. So, up close shot of the finished common mode choke on the feed point. You see the center goes to one screw, the shield goes to the other, and we have the ground here, as well as the center being going to the center pin of the SO239. Now, here is a shot of both lids, and you can tell that this one does have a solid center, and this one has a recessed center. That's a little bit better picture to show the recess, and it's only about 2 millimeters deep, so it's enough that it would allow the coax to go in and still have enough protrusion around the edges to kind of seal off the water. Here is the ZS6BKW assembled with all the 3D printed parts. Here, as well as the isolators on the radiators. If you'll take a look at the end isolators, they are around 3 inches long and just a shade over 1 inch wide. I'll have a link in the description for those. I found them on Thingiverse. One thing about it, that is twice the size of the original file. So in my slicer software, I upscaled it 100%. The ones you download will be half this size. The wire is BN Teco 16 gauge silky wire. It does feel like it would have a good bit of stretch to it. So I'm planning on not having a lot of tension on the radiating elements when I install it. The 450 ohm ladder line is the 16 gauge DX Engineering, and I ordered 50 foot of it because I wanted to have enough that I could do some other little projects off after with the leftovers. The feed point I designed and printed in PETG. And there is a FT240-43 toroid in it with 10 turns of RG8U, I believe it is, the Mini 8. The lid I had to make twice because originally I was going to use some 16 gauge stranded wire to make my common mode choke out of, but I didn't have enough of it, so I had to switch over to the Mini 8 coax. And I'm thinking the next time if I have to do something like this, these screws here, I'm going to spread them out a little bit so that the ladder line can come down and turn out instead of have to go out and turn in. I think that would be a little bit better look on it. And that feed point is printed out of PETG. The dipole center, if you want to call it that, is 3D printed as well, PETG. It's about 1/4 of an inch thick. Strain relief holes for the 450 ohm ladder line as well as the radiating elements. Same screws. The terminals here are ring lugs. They are soldered on and they just pass through and are locked down. I'll put up some screenshots of the inside of the feed point, as well as, if I can pull them back up, some screenshots of the CAD software where I was designing them. That's all I have for today on this project, but keep in mind I still have to finish the remote antenna switch, which I will have a video on that. I want to put up, I'm going to take down my 40-meter loop and reposition it. I'm not sure about how or where right this minute, but it will be reused. The general idea that I have is to have a couple of vertical antennas as well as a couple of horizontal antennas so that I can have some comparison between the two, local and DX contacts. So, like I said, just this is it for today. Guys, appreciate you staying around. The ones that did seem to gain a subscriber and lose a subscriber because I don't put a lot of videos out all the time, but I do it when I can. 7-3, and we'll catch you on the next one.